And now we're getting closer to the end of this day. But first, it's time for us to introduce our third talk, which is going to be given by two speakers, both of them from Vandebron, so very curious about it. The title of this talk is going to be Building on Top of DBT. The first speaker is Mats Stijlaart. He's an analytics engineer here at Vandebron, and Pieter Custers, who's the tech lead data analytics, also here at Vandebron. So without further ado, a bit easier here. I would like a big applause for these two gentlemen.
Thanks. Just checking in with you. Do we maybe need a toilet break? We can have a few minutes before we move on.
Or a drink.
Or drink, maybe. There you go. Take a beer. I'll just share the slides.
Anyone have beers from here?
Let me share my screen, actually.
Anything else than beers as well?
Also at home, please take a beer. It's a box.
So non-alcoholic beers and
Well, let's do the back downstairs.
Er is niemand beneden, toch? Shall we?
Yeah.
All right. Just waiting for one person to come back. There he is. So welcome again, everybody, in our new office, where the cables are still hanging from the ceiling. Hope you don't mind. Maybe you didn't notice, so sorry for mentioning. This is us. Well, this is me with shades on. Well, actually already introduced, but Mats, analytics engineer, me, tech lead, data analytics. Vandebron is only 9 years old, so that gives you an impression on like the fraction of time we're working here. Let's see. So before I introduce the topics, first, so as Vandebron, a year ago, we completely revamped our data stack, and it was really necessary. It was like legacy building up from the beginning. In a startup, you do something else the next day that you did before, and you make random decisions all the time. So we had finally the opportunity to completely revamp it. And this is how it schematically looks like. So we have a Snowflake data warehouse with 4 architectural layers. There you go. DBT on top of it. We have several tools for that we use for ingestion. There's no silver bullet. We took some time to find that out, but in the end, you just need all of them. And then there's a BI tool and whatever else is using our data at the very end of the pipeline. And then there is this new kid on the block, Dagster, which is orchestrating basically everything, let's say 90% of what we're doing. I see a new kid on the block. It's 1 year ago that they went live with the 1.0 version. We've been using it half year before that. Took some risk there, but we're glad we did. It's we'll talk more about it, but where Airflow was always like the tool to go to orchestrate your flows, Dagster is we think the new tool to orchestrate your data assets. So the topics, I'm going to talk about Dagster, and Matt is going to talk about Lightdash. Both are tools that integrate very well, if not seamlessly, with dbt. So Lightdash is built specifically for dbt, and Dagster just released a 1.4 version, which makes their dbt integration just pretty seamless. All right, Dagster, there it is, the first topic. So first, a disclaimer. We never used dbt cloud. We had Dagster earlier than dbt, so we never even considered dbt cloud. But actually, I'm curious. So who's actually using dbt cloud in the audience? That's about like 4 people. I just counted 40 people in the room. That makes 10%, just out of interest. But this is not like an advertisement or product placement like for Dagster. But we really like the tool, and it is the reason that we're not using dbt core. So what is Dagster? First of all, it's it's a Python library to build data pipelines. That's in the core what it is, end-to-end, so to say. So from ingestion, consumption, machine learning models, whatever. This is actually a code snippet. This is essentially all you need to load your dbt assets into Dagster. You might need a schedule on top of it, but that's all. If you can see, I can actually explain. You load the assets, and then you define the resources, so it knows that you want to use the CLI tool to run, to execute runs. Dagster is also a platform agnostic, not native, platform agnostic orchestration tool with a very fancy interactive UI. I'll be doing a demo shortly, so we'll get to that. So why Dagster? You might notice me because you're using dbt. You're already very much used to an asset-centric approach. So in the times of Airflow, everything was a task, and data flowed from task to task. In the time of dbt and Dagster, everything is in data assets. So it might be a table, machine learning model, whatever. But every single atom or increment of your pipeline materializes an asset. In dbt, it's the most obvious because everything is a query. But in Dagster, we also think in a broader context about data assets. What is Dagster more? Why Dagster more? So we have a bigger context, right? So dbt is basically doing the transformation for you in a data warehouse, but there's also ingestion. There's like a staging layer machine, maybe even before ingestion. There's your data warehouse itself. There's Python code on top of that. There's notifications, whatever more. And Dagster is orchestrating that from one single point. So we have basically one interface to see your complete lineage. And most importantly, why Dagster is that we can do declarative materialization. So let's go first to Airflow. So I already told you, Airflow does task after task after task. So if a task X depends on Y and Z, it cannot simply do Z and Y next to each other because they might both trigger X. So you have to chain them, right? So this is task-based imperative workflow, so to say. dbt does already a better job because it can understand the logic. It can understand that X depends on Y and Z, so it waits with materialize in X until both are ready, Y and Z, right? So that's asset-based imperative pipeline. And then there is Dagster. Don't be scared. It's not more complex, it's just offering more possibilities. So let's say that asset X indeed depends on Y and Z, but X becomes stale after 1 hour, for example. Asset Y can refresh basically continuously because maybe you're connected to a transactional database, it's a sync of some sort. And Z is actually irregularly updated. Maybe it's a file that somebody just now and then puts on S3 and you want to sync. So why would you always trigger Z? And why would you continuously refresh Y if X only needs to be updated every hour? All right, so this is my last slide before the demo. So I want to explain some abstractions that we can use within Dagster to do this declarative materialization. So you're all familiar with basic cron scheduling. And I think that's, correct me if I'm wrong, how probably most of you use dbt. It's like this daily run, maybe in the morning that you trigger the whole dbt thing and then it's materialized like an hour later or maybe quicker. Hopefully quicker. So then within Dagster, and actually, so dbt also offers like an API, so you might be able to trigger it like specific models at other time intervals, whatever. That is possible, but still that's an API. You have to implement it somewhere. Dagster did. Okay, so then within Dagster you also have sensors. Sensors basically listen to anything. For example, an S3 bucket. Listens to S3 bucket, hey, there's a new file, then triggers an event. There is automaterialization policies, either eager or lazy. Eager means whenever there's an asset upstream that materializes, the next asset will materialize, and only then. And lazy automaterialization policy means I only materialize when there's new data, and I need to be up to date. Every morning at 9, I need to be up to date, and new data is coming the whole day long. I will only materialize at 9, but only if there's new data. That's what lazy means. I have to note here that a freshness policy, like for example, every day at 9 I need to be updated, is different from a dbt freshness policy. So dbt freshness, dbt checks basically the last modified date of a row in your table. But if your data never updates, you get a warning or maybe even an error while the data is not even stale because it might just not update every day, right? So within Dagster, it means that Dagster at least did materialize the table, right? So even if there's no new data, there was a successful run. That's what freshness means in Dagster. All right, demo time. So this is the context. We are exploring new bars around the office, and but only on days we reach a sales target. Okay, let's go. Let's see. Okay, let's see. This is probably need to zoom in. You let me know if you can read it. Bigger, bigger. It's as big as it gets. Maybe a little. Is this okay? All right. Okay, so this must look maybe familiar. So, by the way, the UI, you're not used to it of Dagster. So, but focus mostly on this view and a little bigger the lineage view, because I might click around a little bit. It goes fast. Focus on this one. Okay. So this is a very simple DBT model, right? You can clearly see the lineage. You can here see the sources and the actual DBT model. So the staging models and marts, just very linear and very simple. And you can already see a glimpse here of the downstream dependencies that DBT doesn't offer that, right? It stops at the marts or at the latest layer. You can already see a feature, by the way, of Dagster here. I just, right before the presentation, updated the demo code. And Dagster notifies me in the UI, hey, there's a new code version. You might want to materialize this asset. And it can also do that automatically. What also comes to attention is this. This one is overdue. So let me click on this. This has a freshness policy that this data should at any point in time incorporate all the data up to 1 hour before the time. So it should materialize every hour, but it didn't. So I will explain later why it didn't yet. Let's see what else comes to the attention. Nothing yet. So let's see the global lineage. So this is already like the bigger context, right? We see all the input and all the downstream dependencies. Yeah, let me glimpse over it a little bit here. So this is an S3 bucket. There is, I can show you here. So this is the clicking around. Now you can see this is a sensor that is checking every 30 seconds if there's a new file in a bucket. If there is a new file, it will send me, send a trigger. So, no new files since I last tested this demo. And these downstream dependencies within DBT have an eager auto-materialization policy, which means, hey, if there's new data, I will materialize. But if not, I will just do nothing. So you don't spend any needless resources. This is also a cool feature, actually, of Dagster. You can partition your data. So this is the sales per day. It will not run the asset for all the sales, for all your history, but only the latest day. So I can just go here, if it allows me, click the latest partition, materialize that. Maybe you changed your code and the sales per day historically changes. I can also select all. Maybe some historical, like in the weekend, it didn't materialize correctly, and today it did. Just select all, and if you materialize, you can backfill only the missing or failed ones. Okay, that's already quite some detail. This is an integration with Airbyte, and this one is interesting because it's not scheduled at all. So it is connected to Airbyte. Airbyte will do a sync between a sheet of participants of these drinks, by the way. These are participants, sales per day, and also, of course, a list of the bars around the office. But this is not scheduled in any way. The downstream asset is also not scheduled in any way, but the downstream DBT asset wants to be updated every hour. All right. So nothing here happens yet, and that's because I disabled auto materialization. But if I enable it, and now bear with me because I really hope it's going to work. Yeah, there you go. So yes, something happens. All right. So this one says, hey, I want to be updated every hour, but it has been quite some hours already, some overdue. And it recognizes that the first thing that needs to happen to be updated is this Airbyte sync. So it triggered the Airbyte sync, and after this one, this will be materialized, and then this one will be materialized, and from now on it will be done every hour. So I didn't schedule anything upstream, only the last one. Now let's go to this. This one is actually scheduled, but yeah, it's really hard to set a schedule at exactly 19.18 hours. So I will trigger it manually now for you. State the latest only. Materialize. There you go. So now this one will materialize. By the way, in the meantime, you can see that it recognized it as upstream data. This materialized. And I actually hope that it will go all the way downstream. Sometimes a little bit laggy, so you have to forgive me for that. This one will materialize soon, as it already recognized. Hey, there's new upstream data, and all these are configured as such, eager that they will materialize whenever there's new data. There you go. Luckily. As you can see, by the way, well, you have to read very carefully, but it's doing this all in one dbt run, right? You can just do that in one run. So dbt is in this case, in this specific case, that they all need to materialize at once, taking over the logic on what should go first. Right, and then we have this third example where we need a new CSV file and a bucket. So let me do that. Yeah, what number? Random number, so you can like see that I'm not fooling you. NZ45, okay. Let's check. So let me first go to that sensor, see if it already picked it up. And well, that actually did. I found the file. So I hover over this, you can see the number. There you go. Okay. If I'm not mistaken, this one is now has just materialized. Let me zoom in again. This one has just materialized, and now it recognizes, hey, there's upstream data, so these assets should materialize as well. What else is happening here? By the way, the executive summary is updated because there was new sales. This is downstream dependency outside dbt. And what I like about this one, this specific reconciliation asset, it communicates to Slack after 8 AM when all my marts are fresh. And this is something you might not be used to, because if you schedule one big run, it's pretty deterministic when that run is finished and you receive a notification if it failed or not. But if all your assets are doing something, well, somewhat predictable, but not really, you might want to set something in place that says, hey, okay, so now we're pretty sure that everything is fine again. This triggers after 8 AM. It already triggered this afternoon. So I have to do it manually this time. It will send me a Slack message, hopefully. See if that happens indeed. All marts and Lightdash dashboards are up to date again. Very glad. Thank you. And a machine learning model is trained after that, because it needs to know that all the marts are updated. Let me think if I'm missing something here. Yeah, there's one thing I want to mention. You can see that, well, you can conclude from this graph that all this code that is in the gray boxes is in a completely isolated, separately deployable Python/Docker image. Docker image with Python in it and Dagster, sorry. It can even be on a different version of Python. It can be on a different version of Dagster. So they can be like governed by other teams. It doesn't really matter. The only thing that links them are the unique asset keys. This is makes it very flexible, the whole thing. So you don't have to deploy it at once. It's basically services that work together. All right. Yeah, actually, that was the demo. let me go back to the slides, because the dashboards are up to date, so Mats can take over from here. But let me first wrap up and I tell you the takeaway. So think assets, not tasks. I think you're already there. With a bigger context comes way more information and way more control over how you want to materialize your assets. And with an asset-based declarative pipeline, you only run what is needed when it is needed. And if you have like very big, working for a big company or have a big data infrastructure, that might save you some costs and hassle. All right, that's the Dagster part. Let's now, there you go, proceed with Mats. We do the questions at the
end. I'll bore you with some Lightdash stuff before. Because I'll take you through how we try to enable self-servicing within Vandebron through Lightdash. First, I'll start off with a disclaimer as well. We still do not use cloud. So we cannot integrate dbt metric flow into Lightdash, so we have to work our way around that. Lightdash does offer a very nice solution for that. So as Pieter just explained, we finally got a very fancy, nicely running, completely awesome data model. However, me in the data team is still getting Slack messages, emails, and WhatsApps even, because everybody has data questions, but not everybody can query data for answers. I think at Vandebron, maybe 15% of the employees can query. That's not enough for us. So I've been being bombarded with questions and basically doing print statements on our Snowflake database. I don't like that. So that's where Lightdash comes into our stack. So in the graph that Pieter showed you before, Lightdash is at the end of our stack, but for the other 85% of the company who can't query, it's basically the stack. It's their only point of integration with our data model, the thing that we've been trying to make as fancy as possible, as nice as possible, as complete as possible, containing all the information that the user wants. We only need something to get it to the user. Well, so how does Lightdash then interact with our stack totally? So it builds on top of existing data models. So it leverages the structure of dbt that is already there. And it executes the queries on our database, which is in our case Snowflake, which is then the backend of our dashboard. And Lightdash, the only thing it adds to it is it exposes it with an intuitive UI, which then the Vandebron end users use. So it's basically the only point of contact with our fancy thing. People have been asking us about our dbt meetup today. We've been trying to explain it. We just say it's the thing behind Lightdash. So the first part is building on top of our existing data model. It might be a little small, but we all know a YAML. It's a dbt file that describes our dbt model. It accompanies our SQL and it gives some context. So we have a name, a description, it maybe describes the columns. At some point you might even describe the columns, depends on how far you are. But you can also add some meta text to it. Meta text can contain anything, but there's also meta text that Lightdash can interpret. So if you rewrite it a bit and add some context, Lightdash only needs a few additional meta text to be completely transformed into a very nice intuitive UI for an end user. And it's very formatable. So you can add information on what is a dimension, what is a metric. You can relabel things, you can reformat things. You can create even new metrics. That's why we are using those metrics now instead of the dbt metric flow. But since we now have a model that's described as such, something that Lightdash can interpret, this is where Lightdash comes in. It transforms the YAML into a UI. So here you see on the right that Lightdash tells you to pick an orange metric. In this case, you could pick sales and take a blue dimension. In this you can take any form of granularity in terms of a date dimension. And this is what the user will see. And it all comes from the simple YAML on the left. The representations of the dimension and the metric are shown in the boxes. So the blue part describes the dimension, and the orange part describes the sales metric in this format. And then that's where Snowflake comes in. So this is the UI. of Lightdash. On the left side, we see the dimensions of sales as I just mentioned. So we basically ask the user for input on our data model. So select the dimension and the metric you want. It constructs a query, which is executed on Snowflake, which you can see at the bottom here, which is actually readable and also copyable. You can copy it and execute it on Snowflake directly as well. However, Lightdash offers you the opportunity in the UI to do whatever kind of visualization on it you want. You can make it a line graph. You can also make it a pie chart if you'd like. I don't know why, but you could. So to give you a bit of a demo of what is possible in Lightdash, I made a, let's see if this loads. So this is specifically for the DBT meetup. Before I worked as an analytics engineer, I actually worked as a telesales agent. So we're going to look at my own sales performance. So this is a general Lightdash dashboard that could be used within the company. You can see it's a very similar dashboarding tool to other dashboarding tools. It allows you to do some filtering, which you can apply. It's very dynamic as well. You can also filter by drilling down into months or whatever graph you want. The whole dashboard goes with it. You can make exports, all the things that you generally expect from a dashboard. But what we really like it for is the fact that we can also now enable data exploration and basically self-service within the company. And how we try to do that with our employees is that we invite them to start building their own dashboards and graphs. So the whole dashboard you saw just now is based on this telesales evaluation table. And for instance, I could be a coach and I could be diving into this and I want to see weekly numbers and I'm looking to the metrics and I see something called sales and cancellations. Two things I'm interested in because I want to know how my agents are performing. But I also know that if I subtract cancellations from sales, I get net sales, which is even more important for me as a sales coach because then I can judge the quality of my agents. So I want to know that. But I also observe that it's not yet. However, Lightdash offers you the opportunity to have very simple table calculations. I could call this net sales. I could just query the sales and subtract the calculations, the cancellations from it, and get it into my net sales, which is very useful for the coaches. But what is very useful for us as well is that they construct something new, is that there's SQL there, which they can directly give to us, and we can implement it in our data model, and that's how they help develop our data model. So there's a very short feedback loop on it, and it helps that the SQL is already there. Besides that, there's the option to actually run a SQL query. So for some more advanced users, they can actually just write a complete query in it, visualize it, tell us why it's necessary to be modeled into a mart, and we can just implement the query as well. So this is what happened, literally. Emails with work requests went down, Lightdash views went up. Although this is based on mock data, this has been our experience in the past year. It's basically some inversion on the month number. I don't know what it is. But this has been our experience from the first year of using Lightdash. A few takeaways from using Lightdash as well is it's an unpaid ad this time, but Lightdash is very fast that they're in developing. They're very cooperative. It's a very good collaborating Slack community, and they're very helpful in helping you succeed. Enabling self-service for us meant giving away control. It's been kind of tricky because everybody can draw their own conclusions. So we had to educate our users in both using Lightdash, the tool, but also in how do you actually draw data-driven conclusions and make decisions on that. But we've been trying to do that by making a custom course for Vandebron, which is just Lightdash in general. We've been giving courses on how to make data-driven decisions. And we've also created a very tight internal community around Lightdash, where end users are helping each other to solve Lightdash problems, and which we're using for releases on our data model side, but also on Lightdash releases. But eventually, the most fun thing has been that Lightdash has been showing up in every meeting. We have a lot of glass around the meeting rooms in the office, and wherever you look, there's a Lightdash graph. Where it goes, it's not a meaningful meeting without a Lightdash graph. So it's been a huge improvement from us. We came from a custom R-Shiny dashboard, so we're very happy. We finally have time to do other things in our job than keeping the dashboard up. So that's Lightdash for us in a nutshell from the last year. Any questions? Oh, yeah. Close enough.
Thank you. I was interested, you showed the DBT job that runs. You pointed that out when you clicked materialize all, and there are like several models that are connected that they run under the same DBT job. Is it an ad hoc created job in DBT by Dagster, or is it some kind of preset job? And
Right.
Because
Yeah.
you can click materialize just certain models, right? It doesn't mean that all of them will be
Yeah. Indeed,
materialized
so-
at the same time.
Yeah, good question. So indeed, it is ad hoc created. Dagster is in my configuration using just a CLI interface, and actually, if I click on it, you can see it. So this is more familiar to you.
Mm.
So it basically runs via the CLI API a specific set of my models. Yeah.
Right. I'm interested about the Lightdash part as well. So you're exposing marts to your users, but in my experience, it can be hard to provide like enough columns of different slices that people can explore while making sure that people still, I guess, know how to interpret the data and know, well, I should probably filter this out in most cases, but for specific use case, I shouldn't. Have you any experience with how you handle that, or is that just a lot of training and making people familiar?
So we try to, you can configure which tables you expose.
Sure.
So for very specific, we have team-based projects in which you can configure those tables. So we try to tailor them as much for based on the team. And then it's indeed about education and also about the strong communication with them and collaboration, because they should feel that there's no hurdle to contact us about Lightdash. So that's why we started the Slack channel internal, and that's been really helping. And we see that teams or users are started to help each other. So that's been a big win for us in that case.
Right. Thanks.
Yeah. So I've also been using Dagster, but I've run into some problems with time-sensitive jobs and jobs which had a higher workload. Do you think that Dagster is also a good tool for those kinds of projects?
Depends very much, I guess, about your use case. But I can tell you something about a use case that we have with pretty high loads. So we, as Vandebron, are a marketplace for energy producers and energy suppliers. We don't have any assets ourselves. We have actually more than 300 producers of sustainable energy in our portfolio, and we need to predict. We need to predict what they're gonna produce the next day, and actually more in the future, but also the next day. So we have we have several hundreds of machine learning models to do so, which loaded a shit ton of data basically in like the weather data, weather forecast, but also production data from the past, etc. You can imagine. And Dagster allows us to run these all in parallel. So then it comes down to the platform that you're running it on. So for us, that's Kubernetes. That really needs to handle the load. Hopefully that answers some part of your question, or maybe
Yeah,
it's not
well,
a big
I use
load
it
for you.
on-prem, so it's
So
I have a separate issues then. I'm running it on-prem, so.
We're running it on-prem as well on Kubernetes.
Oh,
If that's
yeah. Okay,
So
like
we-
single machine then.
Yeah, right. Yeah, okay. So locally, I would not trigger myself that 300 big.
No.
I would probably explode my 2019 MacBook. But what I wanted to add, that was the thing. So we ran into some scaling issues, and that's the fact that Dagster is using one single scheduler daemon that has to handle all your load. So recently we tried to materialize for a day all the partitions, which were minute partitions, which makes a lot of minutes in one day at the same time. So that was too much for the scheduler to handle in a smooth way. So this is also something we walked into, and we found that the Dagster community indeed was flagging.
Yeah, I had that as well when running a big, large backfill.
Yeah, backfills are typically indeed very much prone to these issues. Yeah, but I'm pretty sure. Well, I'm pretty sure that they are looking into it. At least it's a hot topic in the community. And I've read about some workarounds like that you can use multiple daemons who are like that. That's not
multiple
coding
code
it.
locations, and then one you can use like a different executor, and then it will. You can
That's
speed up
maybe
things,
also
yeah.
possible. Yeah, indeed. I mean,
Instrumentation.
in that way, you could be smart about it, right? It doesn't matter where your code lives. Basically, it can even be multiple GitHub repositories. So it can also be multiple instances, namespaces, many nodes in your cluster. Well, your local machine that probably does not have a lot of nodes. But hope that helps. But also, I'm happy to discuss later.
Yeah, let's do that.
Oh, so that's the downside of everyone sitting down. You have to turn around to throw the microphone. Thank you for a great talk, both of you. I'm noticing you're standing apart a little bit as well, which symbolizes the man in the middle, or the person in the middle that I want to talk about here, which is data modeling. There we go. So I'm going to preempt the question Nico, I'm sure, is thinking about as well, which is how do you model all of this data? And when you re-architected a year ago, did you re-architect your data model from scratch as well? And if so, can you share a bit about just the high-level philosophy that you followed there, Inman or Kimball? Right?
Yeah, I think Mats is the best answer.
So yeah, a year ago we had I don't know how many separate Python jobs doing well every transformation again and again. 118 I hear, which basically all did the same transformation every day and F failed every day. Then Tim came in as a manager and he said, you know about DBT? We said no, and we started looking into it. And we have since then started to model it where we model it across our known entities. We are not, it's a very slow, well, the thing about our product is everybody has an energy contract once a year. So we're not so interested in transactional data. So we're fine with just latest state. So it's very simple, basically, for us to just have the latest state of an energy contract. Doesn't change that much. Maybe it changes the name, but we don't care about the name because nobody's going to join on that. So we have modeled along our entities, so seeing things like an energy contract. And then for complex explosions, we use intermediate. And then we go mostly to per day into marts, because that's also where your question maybe comes from. Then we limit the freedom of the end user a bit and give them a very plain playing field where they can just send sales over days, weeks, months. So it's very simple for them to use in the UI, and it's very easy for us to prep it as well.
Yeah, indeed. And in other words, yes, we completely went back to the drawing table and redesigned our data model. But we're not living in a perfect world. No. So And we also have like a secondary infrastructure to keep alive at the moment, which is really nagging. So we're going to shut it down next week, and not everybody is yet aware of that.
Are those the wires hanging out there? So
No, but very soon, and this puts pressure on other teams to move, and they might do it quick and dirty.
Yeah.
But then again, it's evolutionary. At least now everything is in the picture. Everything is versioned. Everything is in scope, and we designed it in such a way that the interior of our DBT data model, so not the marts where everybody consumes, and not the ingestion part, but everything in between, is we can keep on changing it. We can keep on refactoring because nobody is stepping on that directly, and even the outer shell is a view on. Always a view on like the shell before that, so that we can keep on changing basically everything, only the outer layer.
Yeah.
So we designed it for an evolutionary way, so to say.
Sure, the fact that you moved to a new office has nothing to do with the fact that you're killing the legacy infrastructure somewhere. It's all.
It's actually a physical server at the old office. One more question there.
Yeah.
Nice
I
catch.
have a question about Lightdash. So you said that it's completely controlled by YAML files. So it's not an easy job to kind of validate all these YAML files. How do you, and does Lightdash validate them somehow? And how do you push everyone to basically write down all these endless characters in the YAML file?
Yeah, good question. So we have a pretty small data team, so that keeps control over the YAMLs as well a bit. What's also really nice is that Lightdash has a CLI which offers you the opportunity to run it against your Snowflake warehouse. Then it can add a lot of context for you as well. So it can add data types automatically. It can tell you things like that already. So that's automatically done. You can also use CLI to validate your current YAMLs against your production YAMLs. So what's actually running in your dashboard. So you can check if you change something in your YAML, does it break a dashboard anywhere, which is really nice. You can also create a preview of it. So you can actually go into a preview dashboard, create a toy around, even give it to an end user, say, try and break this, does it work for you? And then you can deploy it. So they've thought about this as well, because it's a hassle, the amount of YAML files you do have to manage. But we're already managing a lot of YAML files with DBT, so it's a bit of an extra step.
Thank you.
One more question there, can you for the box?
So about the demo, which bar did it recommend based on your sales performance?
Come again?
Which bar did it recommend to you? The demo.
This one.
Actually,
Yeah.
Blauwhoofd, indeed, it's across the street.
Okay,
So,
good.
there you go. That's good.
Thank you.
If that's the final question, then
Now we're good to go.
that suggests let's stay here for a beer, and I'll hand it over to you one more time.